Hello, so this recording is going to focus on statistics, and particularly here I'm going to talk to you much more about the inferential statistics, although I'm going to begin by just a little bit more on comparing variables descriptively first. But as you can see, these are the things that we're actually going to go through in this session. So, in Statistics 1, I covered things like cross-tabulation and comparing means. And actually, you can present this kind of material using a range of different graphs as well, and this was something that I wanted to flag here. So, for example, you can compare different groups of people and their responses to a question doing a bar chart. So here I've got the percentage of men and women relative to how long they're planning to stay at a site. So this is in a tourism context. And you can see actually, according to the bars for men and women, there's actually not much difference between the two. But women perhaps slightly more inclined to stay longer at the site. And also we can compare means. So here we've got some statements to do with, well, the first one's to do with preservation of the natural environment, visitors being required to pay more for the car parking they use, things like that. So some attitudinal statements. And these are all done on an agreement scale from 1 strongly agree to 5 strongly disagree. And again, this graph has plotted this for men and women, what their mean score is. And actually, again, if you look at the bars for men and women, you can see they're really very similar. So the green one about preservation of the natural environment taking priority, the mean score for both men and women is round about 2.3. And is very similar. So, mostly they're in the agreement category, really, I would say there. Whereas actually the green bar, visitors should be required to pay more for the car parking they use. You can see that the answer options there for both men and women are the mean of nearly 4, which would put them in the disagreement category. So it's quite a good and useful way to visually represent data, but you can see straight away here that there's no gender differences. So then you might need to think about choosing statistical tests. So you've done some descriptive analysis and you actually think there might be some interesting patterns in your data, and also you've hypothesised that there might be certain patterns in your data and certain relationships between variables. So when we come to choose statistical tests, it depends on a number of things. So first of all, the nature of your data. So first of all, how many variables it is you're wanting to compare. Now, really, for where you are in your stage, and doing a dissertation, I would stick to comparing 2 variables. But those of you who've got a bit more background in statistics might want to do something that involves more than 2 variables. But I'd only recommend that if you've got the some competence in this already, and maybe you have a supervisor who can support that. So, typically we might be looking at 2 variables, so 2 questions in a questionnaire. And then the type of data you've got, whether it's nominal, ordinal, or scale, and that will determine to a large extent what statistical test options you have. Then there'll be something about the sample characteristics, so the number of groups. So do you have 2 groups you want to compare? Maybe you've got local residents and you've got tourists in a tourism study. Maybe you've got people who take part in a particular sport and people who don't take part in a particular sport, and that gives you 2 groups of people. You might have more than 2 groups. So for instance, age groups tend to put people into 5 or 6 different groups depending on their age category. And then other issues are the sample type, whether it's independent or paired. Now, most of your studies are likely to be independent samples, but occasionally I have students who have done a paired sample, and this is typically where you might have before and after measures. So you might measure people's attitudes to something, then maybe expose them to some kind of media, maybe a video or some advertisement about something, and then test them again on the same questions. That's a paired study. And if any of you are doing that, I don't particularly cover the statistics on that, but if any of you are doing a paired study, I'm quite happy to offer some guidance on that, and so will your supervisors. And then the last thing is, what is your hypothesis or research question? So are you needing to compare some? Are you looking for an association between the 2 variables? Are you looking for a difference between 2 groups? It's that kind of thing. So it's, what is your question? So if you go into the textbooks, you will find tables very similar to this, and these are what you use to work out which statistical test you need to use, if you don't already know that test. So you can see that along the top there we've got whether we've got nominal, ordinal or scale data. And then we've got some different questions down the side there. So for instance, if you want to look at, see if two groups are different, and this is something very common in a dissertation, so you might want to compare the attitudes of men and women, you might want to compare the attitudes of people on the basis of, something like level of engagement in an activity, and you might put them into groups according to very highly engaged or much more limited engagement, for instance, maybe in terms of something like sport participation. So you want to compare two groups, and if you've got nominal data, so the question you're interested in is it's got categories, then you can use a chi-squared test. So for instance, if you want to compare two groups and how they have travelled, the how they have travelled question will be nominal data, and the only thing you can use there is a chi-squared test. If you've got some ordinal data, so maybe it's a sort of attitudinal question, and you've got a Likert type scale from strongly agree to strongly disagree, then you could use the Mann-Whitney test. And actually, if you have scale data, which not many of you will have, you could use t-test. Now, I don't teach the t-test, partly because I have very few students who have it, but some of you may be very familiar with that, and that's absolutely fine. And it's very easy to do as well in SPSS. Then you might have a question about whether two variables are related. So is there an association or correlation between two variables? Now, if your variables are nominal, the only thing you can use is a chi-squared test. If they're ordinal, so if you've got two agreement scales, so you want to test some kind of agreement with one concept and agreement with another, then you could use the Spearman's rank correlation coefficient. And if it was scale data, you could use the Pearson's product moment correlation. Okay, so you get the kind of picture, and you can go down here and you can see if are three or more groups different. And also you probably pick up quite quickly that if you've got nominal data, you're pretty limited to the chi-squared test. But if you've got ordinal scale data, other tests are available which are a little bit more powerful. And actually you can do analysis with ordinal data with relatively small samples. So you might get away, if you want to compare two groups of people and you've only got 50 respondents in your study, you might get away with doing a Mann-Whitney test. You probably won't get away with this if you're doing a chi-squared test, where you tend to need more data. Okay, so let's talk through some of these tests. So the first one is a chi-squared test. And basically it tests how likely it is that variables are associated, but also we can use it to test whether there's a difference between two groups as well. So I've got an example here where we collected some data on the National Trust. National Trust is a big heritage organisation in the UK, and some people are members of the National Trust. And we compared members and non-members, and whether they would visit a particular National Trust property again. And they either gave the answer yes, no, or don't know. And so you can see the count data in that table is what we've actually found from our study. And then we've asked SPSS to generate an expected count data. You can also calculate this manually. And I think one of my worksheets online shows how you do this, but you wouldn't want to because SPSS will do it for you. But what the test does is it basically it compares and looks at the difference between the count data and the expected count data. Now, if you look at the patterns in that table, you can see that they're not actually that different. So I wouldn't expect there to be a statistically significant pattern here. And in fact, underneath that table, I've reported the chi-squared findings as generated by SPSS. And in chi-squared test, we report the chi-squared value, which here is 0.383, the degrees of freedom, which in this case it's 2, and then the p-value. This is where I talked about this idea of probability. It's often given the title significance in the statistical tests on SPSS. And here that value is 0.826. This is a lot bigger than that threshold value that I've talked about, which is less than 0.05. And therefore we can conclude that there's no significant association with membership and whether people would visit the property again. Okay, because there's no difference between the members and the non-members according to that test result. So the key thing here to look at is that p-value and whether that is less than the 0.05. One other thing to add there, students often do things like this and go, oh, well, I haven't found anything. And I'm kind of going, well, you have, you've just run a statistical test. Because they haven't found a significant pattern, because that p-value is not less than 0.05, they think they've not found anything. And actually, of course, you have found something. You found that there is no relationship between membership and whether people would visit again. And that can be quite a significant finding, quite important to be able to know that. So don't dismiss it when you kind of go, oh, well, there's not a statistically significant finding here, because actually there is still an important finding there. Then if you want to test whether groups are different in their response to an ordinal or scale question, we've got two options here. If you've got two groups, so, the classic example is men and women, but you might group them in other ways, whether they take part in a sport or whether they don't take part in a sport. You can put them into two groups. Then the Mann-Whitney-U test is a good test. And what the Mann-Whitney-U test is, it takes your answer to the ordinal question and it lines up those scores from the smallest to the largest in order. And then it compares the two groups. So if you're looking at men and women, it looks how they fall in that ordering to see whether maybe you've got more men lower down that ordering and more women higher up the ordering. And that way you might get a statistically significant difference between men and women and how they have answered that ordinal question. If you've got more than two groups, there's another option which is called the Chisquared test, and it actually operates on a very similar basis to the Mann-Whitney-U test, but it allows you to compare three or more groups. So the classic one is students want to compare people in different age groups. Now, depending on how many age group categories you have, typically people have between 5 and 6 different age group categories. And assuming you've got a large enough data set that you can compare 5 or 6 groups, the Chisquared test could be very good there. So it's very good for things like attitudes, motivation, satisfaction scores that people have given you. Another thing you might want to do is look at the relationship between pairs of variables. So if you've only got nominal data, all you can do is chi-squared test. So for instance, if you wanted to look at an association between the day of the week and attendance at sporting events, so both of those are going to be categorical data, because data about the day of the week is the name of the day of the week. Attendance at the sporting event is yes or no. You've got two nominal variables there. If both of your variables are ordinal or scale data, then you've got other options like this correlation option, Spearman's rank correlation coefficient. So if you want to look at whether satisfaction correlates with spending at the restaurant, or whether motivation to be with friends correlates with length of stay, then your satisfaction will be scored, and spending will be an amount. And if you were looking at motivations, this would be on some kind of scale, about strongly motivated to no motivation, something like that. You'll have some kind of scale there. You can use this correlation. So correlations, this is one of age and height, which is a classic correlation, or at least up until people have reached adulthood, where you see a correlation. So this is what it's looking for, but we can do that with ordinal data as well. Then you need to think about reporting results. So I always get the textbooks out and check the details of what you need to report for a specific test, particularly if I'm not very familiar with it. Now, my favourite textbook on this is this one by Andy Field on Discovering Statistics, using IBM SPSS Statistics. Now, unfortunately, it's not available online as an online book. I found another one which is also very good, which is on your reading list, but I would recommend sort of looking at that. So typically, when we're reporting statistical tests, we report as test statistics and a probability value, a p-value, which is our significance value. And for example, I've given a chi-squared test. Now, you might want to report it in a, let me show you like that, where we've put in the cross tabulation, and then we've reported the statistical results underneath the table. Or, as we've done here, I've just written it as text. So 6% of men enjoyed the sport event compared to 44% of women. But then, however, no significant difference was found in the proportion of men and women who enjoyed the event.
And I've reported the Chi-squared test results, and that p-value of p equals 0.39 in this case, which is larger than that 0.05, and hence there was no significant difference between the men and women. So there's no easy way around this. You are going to need to use the textbooks and read around the statistical tests. But, going back up to that table I showed you, so let's just flick back to that, you can use something like this to work out which test you need to do, and then, go and look at the textbooks and read around it. So, the Andy Field book provides step-by-step instructions. There's another one, I've forgotten the author's name at this moment, that I've put on your reading list that will also give you step-by-step instructions for doing it in SPSS. So they are very helpful for helping you through these. And obviously, you can see supervisors for support.